All right, we're talking forces. So that means force diagrams. And I came across this gem in one of my comic books, and I was like, I have got to draw a force diagram of this because I'm not exactly the biggest fan of Superman, and Wonder Woman is awesome, especially in the reboot of the New 52. Big fan of that. So we're going to talk about drawing force diagrams and how do you actually go about it. So first things first, let's pick a color that's going to show up. And I have no idea because this is just too darn colorful. So I guess we'll try purple because there's no purple in this. And first things first, we're going to choose our system. That's the very first thing you always do. So I'm going to choose my system as Wonder Woman. So I want to know what are the forces acting on Wonder Woman. So I always put a little dotted line around whatever the heck my system is. And I'm going to assume that she's touching the ground because I could not find a better picture, where she's touching the ground. So I'm just going to assume that her foot's on the ground. She's not flying through the air doing this awesome kick. All right. So we're now going. I chose my system as Wonder Woman. So now I have to show my art skills, and I have to do my best drawing of Wonder Woman. So here we go. Be prepared. This might take some time. Wonder Woman. Done. Look at that. It's an awesome drawing of Wonder Woman. All right. So now I've chosen my system as Wonder Woman, and I have drawn a picture of Wonder Woman. So now I'm going to ask, what are the forces acting on Wonder Woman? And I'm going to make a few assumptions in this just for teaching purposes that are kind of there, kind of not. But like I said, the picture was so awesome, I had to. All right, so we're going to look for anything that she's in contact with. All right, so I'm going to pick color. There's really no green here. So anything she's in contact with. So right now she's in contact with the ground. And I'm going to assume that she's in contact with his face or his chest just for teaching purposes, even though she's, not exactly. So those are two things that she's in contact with. So then based on this, I can now say some forces that must be present on her. Okay, so here she's in contact with the ground. And I'm just going to say she's in contact with Superman. All right. So based on that, I can start drawing some forces on my force diagram. So first of all, the ground is pushing on her. It's pushing her up. So I have one force of the ground pushing her up. So since a push, it's a normal force. Force normal on Wonder Woman by the ground. Okay. And then Superman, well, we don't. She's kicking his butt, well, his face really, but we want to know what is Superman doing to her. So she's pushing on him, but according to Newton's third law, in our definition of force, it takes two objects to create a single interaction. So therefore, he's actually pushing back on her. So she kicked him to the left, so he is actually pushing back to the right. So that's a normal force again, because it's a push. So force normal on Wonder Woman by Superman. All right, notice my on by notation. So it's always on my system by the other object. And then we always have the ever-present force of gravity on Wonder Woman by the Earth. Yes, on this one they are on Earth, sometimes other planets, but we're on Earth. And then finally, you have to say, well, if she planted her foot and kicked him that way, normally she would want to go flying in this direction here, but she's not. So therefore, we probably have some friction. Okay, so I'm just going to say we have some friction. And since Superman would basically be pushing her this way, because he's in contact, so he's going to push her that way. Superman's trying to push her that way. Friction's going to say, no, not going to happen. So friction always opposes that intended motion. So here we're going to have the force of friction on Wonder Woman by the ground. So it is possible for the ground to do two things. The ground not only did a force normal up supporting us, but it also did a force of friction that was keeping us from sliding. So the ground can often add two forces. All right. Now the last thing we do, once we've got a beautiful force diagram, is we want to see what type of motion do we have. So we ask ourselves, do we have balanced or unbalanced forces? And that's based on the type of motion. So if we have constant velocity, then we must have balanced forces. And if we have balanced forces, we must in turn have constant velocity, so it's a give and take scenario. Now, if we believe we have acceleration, then we do not have balanced forces, we actually have unbalanced forces. For CES, good spelling. All right, so now how do we show this on this diagram? Well, vertically, she's not jumping up and down. There's definitely no acceleration. So vertically, it's definitely constant velocity. So I show that by putting these little tick marks. And so what that means is it tells me that this force is exactly equal to this force here. Let's say that even though these forces are acting and friction's trying to slow her down, let's say that she's just accelerating right into his face. So let's say that we are definitely having some form of acceleration. So we've got acceleration in this direction. So what that means is that these two forces here in the x-plane are not balanced. So I don't know which one's bigger. I mean, well, actually this one, I know this one's bigger because we're accelerating that way. So this has to be the bigger force. But I do not put any tick marks here because those forces are unbalanced. Now that's only if there's acceleration. If I said, oh, and then she's kind of standing there striking a pose, then I'd probably say these are balanced, and I'd put a separate set of probably double tick marks here because I have singles here to show it's different. But that's basically how you do your force diagrams. And just in recap, the key elements of any force diagram is one, that is so not what I want to do. Why would you? No. Thickness, thickness, thickness. Dude, hold on. Technical difficulties. Let's go to my bread and butter here. All right, so one, you need to choose that system. And you can choose more than one object in your system. That's cool. So I could have chosen both her and Superman if I wanted to, and then I could say where the force is acting on them together as an object. And then I would not have this force on Superman by Wonder Woman and vice versa. So then two, identify any contact forces and objects causing them. So here I had the ground and I had Superman. And then three, you would then any non-contact, which is basically, for our purposes, gravity. There are some others, but we're just going to play with gravity. And then 4, draw all forces with that on-by notation. T-A-T-I-O-N. And then finally, oh, I couldn't get it all on one page. Oh, finally, slow down. Then, oh, really? Finally, identify balanced forces with those tick marks. All right, and that's basically how you do your force diagrams. So this is so important because once we have all this done, we're going to build off of it. And we're going to put some numbers with it, and we're going to use it for equations and purposes and all that fun stuff. So that's how you draw force diagrams. I hope you enjoyed the show.